Okay, let's give it a half a second to figure out where it is. See, these are both come up.
Coming up, yeah, okay.
And my number's steadily creeping up. I'm at 60, 65. So if I'm on the controls, I back off just a little bit. Because we just went over 70. Just a hair back toward the negative.
You're looking to get between 50 and 70?
Yep, and I prefer 70, you know, to be honest. As close as I get to supply pressure, the more power I have, right? So when I train my guys in the shop, I say 60 and 70. You can get above 60, and you can see it settling out here about 65. As long as it doesn't creep much lower, I'd probably call this good. But you kind of give it a minute to breathe and see what it wants to do. Okay, we haven't gone below 64, so I think we're good.
All right.
So we'll call that good, and I'm going to hit next. And then it's going to continue on to auto-calibrate travel. There's another warning that it's going to move. Also, it gives you in the middle there, it gives you a little note to return the cover on there. I think it's because they don't want you to have to listen to it hissing.
Yeah.
But I don't mind. It's a good good practice to get to hear this thing breathe.
Yeah.
I get calls from people I've brand new positioner and it's leaking, you know, and they're just talking about this breathing. I wonder if we lost communication.
No. The Blue 734 matches the Maxxis, so this is still showing that. Now, that's setting it to be for the... No, that was too much. So, well, so because the computer can actually communicate with the blue power, but there's no reason for ammeters to be.
Yeah, do you want... We need this to go.
We need power,
Oh,
right?
we lost. There we go.
We lost our
Our new
power.
calibrator. All right.
That's the general idea.
You may not know the details.
They time out sometimes.
They do.
Where you want it at?
Something, you know, above 4. If you get to 12, that's fine.
Yeah.
There we go.
There we go.
Okay, let's try this again. So it tells you right here it's looking for the high drive point. You'll see output A is all the way at supply and output B is all the way at 0. That's normal for a double acting at high drive point. 104% travel. That's how close you got to your travel sensor adjust. You were within 4%.
Really? Pretty good for eyeballing it.
Yeah.
It is a little slower than the analog if you've got a flute right there, but if you've got to, you know, like have you out there or call an operator and tell them to pump it up, small, give you the ability to say small, medium, and large increase.
Okay, calibration is complete.
No, we're fine, yeah.
Now if we wanted, we could just go ahead and put it in service and be ready to roll. If you want to go ahead and do a little bit of extra credit, we could go to the detailed calibration or detailed configuration, and because we're using ValveLink, we can grab all of that configuration like this. I'm going to read the entire configuration. Take about 30 seconds. We'll take and read directly from the hockey puck here, and then I'll have a chance to save that data on my laptop. So that, let's say that I work in a plant where Bubba comes behind me and makes some little changes that I'm not real thrilled about. I can save my configuration and come back behind Bubba and fix it.
Yeah. Call back here.
Yep. So I read the configuration and now I'm uploading it all from the positioner to my database. And my database matches right now, so I'm going to save it. And now I have a record of how it was configured. So if I come back a year from now and find something different because it's not working very well, I can pretty quickly find how it got reconfigured and where the mistake was. And then to run the valve signature, we can see here, there's no data. One of the things I could have done, I guess, moving back to the configuration is enter some data. Oh, I have data. Okay. We have data already on the DVC about the valve it's assembled on. So this is a step they save in the newer firmware. You used to have to enter all that data. Somebody entered it ahead of us. Now that the data resides on the DVC, all the tag information, that's new. It didn't used to do that. So when I hit run diagnostic, the first thing it's going to do is read all that data, and it's going to upload it into the database here. Now all we're going to do, this is the total scan. It's going to run it down to 0 signal. It's actually going to give it minus 5% signal, and it's going to ramp it up to plus 105. Over about 50 seconds, it's going to reverse and come back down over 50 seconds. The whole time it's going to track several things. It's going to track the input signal, it's going to track travel, it's going to track the pressure differential between these two gauges, the two output ports, and it's going to track the drive signal. And from that we'll generate the 3 graphs that we looked at this morning.
Right now. Okay, cool. That was Jeff.
Thank you.
Yep. So then we'll get a valve signature after this?
Yep. Well, this valve signature is one of the graphs we're going to get.
Cool.
So they used to, originally when they marketed it, they called it the valve signature, this diagnostic. And somebody thought that was a good name for it. And then somebody else liked dynamic error band, and so they called it that for a while. And now the way they did it, they call it a total scan, and they separated it. The 2 primary graphs, one of them they call the valve signature. That's the one that looks at the valve friction profile. And then the other one they call the dynamic error band. That's the one that looks at the overall performance from input to travel. And I like the way it worked out now, because we've got a name for everything.
Yeah.
The total scan grabs you 3 data sets, and you still have the marketing value of the term valve signature and dynamic error band. They just mean something a little more specific nowadays. When I started back 15 years ago, everybody was talking valve signature, and what it was about is a signature profile. A signature friction profile of your control valve, and if you take it when it's brand new, then you have that new data set to compare over time. You can watch your valve perform, every year run a valve signature and compare it to the original data set, and you look for changes in friction, and then because by that you basically determine whether or not you need maintenance. You can be kind of proactive that way. You can see the degradation in friction profile and determine it's time to start ordering parts and scheduling a crew to have a look at that valve before it completely breaks down on you.
Oh, so can we turn this back on?